Now, last week, we went over the that's called linear equations. Yeah, the reason we call it's linear equations because the x, the variables, it's just by itself. We can have 3x plus 4 equal to 9. Okay, so and this one is just by itself. But if we got something like this is very simple. X squared equals to 1. We have an x term, which basically says x times x equal to 1. Well, this is called quadratic equations. Now, quadratic means 4, but there is only 2. So why we call that? Well, the reason for that is if you have a square, if the length is x, then the area is x squared. Well, for a square, we got 4 sides. So that's where the quadratic comes in. Now, quadratic equation, the biggest difference, besides that we have x squared term, is that typically we have 2 solutions. Now, linear equation, we see that early on, like say a pretty simple one, equals to 9, then x has to be 3. Only just one solution. But quadratic equations, if you look at this very simple case, that we have 2 solutions because x can be 1 or x can be -1. Both will satisfy this equation. That means if we want to figure out what's the value of x such that when you square it, give you 1, we have 2. X could be 1, x could be -1, because 1 times 1, that's easy, just 1. But -1 times -1 is also 1. So we have 2 solutions. So this is the biggest difference between linear equations and quadratic equations. So quadratic typically have 2 solutions. And the reason I say typically is that sometimes you may not have a solution. Okay, and sometimes you have 1, but typically it has 2. And the way we solve quadratic equations, we basically have 2 ways to doing it. One is called factorization. And the second one is called completing a square. Completing a square. Now, factorization is typically easier, and complete square take more work. But the nice thing about completing square is that the procedure is the same. Or we can say the algorithm is the same. The step, exactly the same steps we have to go through. So therefore, from that, we develop a formula. Now, this formula is called quadratic formula. And that just gives us just a formula to use, and then make things easier for us. So this is basically 2 things we're going to review. One is how to solve quadratic equations by factorization or by factoring. And the second one is solving quadratic equations by using quadratic formula. And which actually using formula is a big part of algebra. Now, in order to say we have learned algebra, or we say we mastered algebra, then we need to know how to do 2 things. The first one is to develop or sometimes we call that derive formulas. So that means we can come up with a formula. And the second thing is how to use formulas. Okay, so that's why we are pretty emphasis on how to use the quadratic formula, but also know how did we get this formula. Okay, this is part of things we reviewed today. Okay, so now let's looking at the factorization. We use factoring, and this is actually a way to solve quadratic equations by noticing a fact, is that if we got two numbers, two unknowns, well, we also A times B. If they're zero, then we only have really three scenarios this could happen. Either A is zero, if that's the case, really doesn't matter what B is, or B is zero. Now in this case, we don't care about what's the value of A. Or they could be the same, A equal to B equal to zero. And that's something called zero. This is what we call zero product property. And we are going to use that to solve quadratic equations. And this can be used in many different, solving different problems. And it's very important property that we use in algebra. Okay, so now we know that we have, for example, x squared plus 4x plus 3 equal to 0. How do we solve that? Because this is x squared here. And what we're going to do is that we are going to break this into this form, x plus a number that says p, then x plus a number that says q, and equal, we basically change that into this form. Now, if we change to this form, then then we use the zero product property. We could either have x plus p equal to 0, and then we just solve that, x equal to minus p. And x plus q equal to 0, then we got x equal to minus q. Now, in this case, how do we figure out what p and q is? Well, notice that we basically changed this expression into this expression. So therefore, they are equivalent. That means x squared plus 4x equal to 3 should equal to x plus p times x plus q. So basically, we're going to go, we did something before. If we say x plus 3 times x plus 2, we call it expanding. We can expand that, x times x squared, x times that plus 2x, 3 times x, 3x, then 3 times 2 is 6. That gave us x squared plus 5x plus 6. This is called expansion. This is something we did, reviewed about 2 weeks ago. And we're actually doing in the reverse way. While going expansion is that we have two expressions multiplied and just give us one expression. But here we actually turn this expression into the product of two expressions. Okay, so if we do that, and we can say because they are the same, we know this side is x squared plus xp plus px plus pq, and this is x squared plus p plus q and x plus pq. And now we notice that p times q is 3 and p plus q is 4, which means that if we figure out two numbers multiply give you 3, and the two numbers add together give you 4. Then we can turn this into this equation into this product of two linear expressions, and then we just use the zero product property to solve it. Okay, so let's see how we do that one. Well, first of all, we want to figure out numbers that multiply give you 3. This is the last one we have to worry about. Okay, well, we know 3 we can either break down to 3 times 1 or 3 minus 3 times minus 1. So only 2 ways we can do it. So therefore, see which one works. Well, if we use 3 times 1, 1 times 3 give you 3, 3 plus 1 is 4, so that works. If we use negative 3 times negative 1 is 3, but add together negative 4, and that doesn't work. So therefore, we actually made that into 3 times 1. Now, to make our life a little bit easier is to notice that this, we can break down to x times x. So therefore, we can turn this thing into x plus 3, because this is positive, times x plus 1, and that equal to 0. So therefore, what we got here is x plus 3 equal to 0. Then that gave us x equal negative 3. And we could have x plus 1 equal to 0. Then we got x minus 3. So what basically we're saying, knowing this is given, and we find the two solutions. One is x minus 3, and one is x minus 1. So which one is actually the right solution? I mean, both we can say they are the right solutions, but depends on application. Sometimes the things we in reality we have to say physics, say we're trying to do some measurement or solving some physics problems, then sometimes we can figure out which one actually is the real solution for the problem at hand. But as far as mathematics goes, we are looking at all possible solutions. That's why we have two solutions here, because both can satisfy the equation here, can make this equation true, and that's what we're trying to figure it out. Okay, are we good on this one? Grayson, are we good on this one? Hello, Grayson, are you there? Hello, Grayson?